Hello and welcome. We continue with the videos from mechanics statistics. As I did mention, I isolated some questions from the papers mechanics statistics from our paper S. So I've done two questions already on previous videos on statistics, one on binomial and one on Venn diagrams. I skipped this one because this is just a nightmare. It's a really long and quite disgusting question on 2 pages. The last question on the statistics. And I think for mechanics, I have here maybe 3 questions. 1, 2, it's in yellow there, 2, and I think 3 there. So let's have a look at what's the questions for today. The question for today, I think, is a question on vectors. This is question 10. I'm going to do question 10 today. I'm going to do question 9 on another occasion. So, okay, well, let's have a look what it's actually saying. I will record this information down anyway, so when I put the paper away. Relative fixed origin, blah, blah, blah. Thank you. A particle P is moving from point A to point B with constant acceleration of Pi plus Qj meters per second, where P and Q are constants. The velocity of P at A is this, and the velocity of P at B is this. If the magnitude of the acceleration is 3.7, find the value of P and the value of Q. Okay, seems easy enough. So let me just sip a little bit of my coffee. Okay, and let's start recording. What do we know? The velocity of the particle at the point A, and that's at the point B. So we have some kind of reference. Velocities is going to be U and V. Arbitrarily initial and final. I take to be U and V. And I'm going to drop the I's and J's, and because we're in 2 dimensions, let me use column vectors, something I will very rarely actually do. At A, the velocity of the particle is 10 minus 13. And the velocity at B is 22, 22. I hope I haven't done a copy and paste, because I don't like the look of both being the same there. And what I have is the magnitude of the acceleration. So the magnitude of the acceleration is 3.7 in units, meters and seconds. So the question is P question mark, Q question mark. All right. It's not actually, it's a 9 marker. It's got quite a bit of work. But it's not actually as bad because there's not a lot of information being given. So first of all, we can see perhaps V is equal to U plus AT is where we need to start, because we got some quantities in there. So 22 is equal to 10 minus 13. I'm going to write the acceleration rather than writing it as A. I'm going to write it as P and Q. In fact, I should have written here, because the question does mention it. The acceleration is, in fact, PQ times T. So essentially, we're going to get 2 equations. And this one says PT is equal to 22, take away 10, which is 12, and QT is 35. For me, straight away, as soon as I see these numbers, because I know my Pythagorean triples, well, I used to know them to quite, we got 3, 4, 5 in these multiples, of course, then 5, 12, 13, the 8, 15, 17, the 7, 24, 25, and you got that 20, 21, 29, you got the 12. This is the one that I'm looking at the moment, and it's debatable which one is the next one, 9, 40, 41, and then it goes on. I used to know maybe another 2 or 3, but these are useful, 12 and 35. As soon as I see that, and of course I got the 37. Of course, you have a calculator in these days, but it does experience and sometimes knowing number facts and a lot of stuff does help. So at the moment, for me, this I would have just finished it off in 3 lines. I can see what the numbers are actually, but we will continue. So we'll pretend we don't know this kind of stuff. So we got these 2 equations to solve. Unsolvable, of course, because there's 3 variables. There is a third equation which says the mod of A is 3.7. So that basically means this fact. So if we square it, p squared plus q squared is 3.7 squared. And now we have 3 equations. And what we can do in there for this particular question, there's several ways we can deal with that. Either get rid of the t's to start with, and we have a p and q out of this, and the p and q from that will finish the question off. Many different ways you can solve this. I'll show you a few techniques, I suppose. Divide this equation, so we're going to have p over q is equal to 12 over 35. So we're moving this equation to something like this. And then if we take this equation, what can we do? Because we got this p over q, we can actually say p squared over q squared divided by q squared is 1 is equal to 3.7 squared divided by q squared. I hope you can follow what I'm doing. This is, of course, not the only way you can do that. You can do whatever you want. I mean, you have so much variety. And if you look at this now, p over q all squared is going to be that squared. So it's 144. 35 squared is 1225 plus 1. I don't know what 3.7 squared is, but I'm not intending to. So it's the q there. I'm going to write it like that. So for this particular one, we're going to have, of course, 1225, 1229, 1369 over 1225, which is a perfect square. You can, of course, use your calculator and just say, I have a calculator actually with me today. I should be using it perhaps so you can see the numbers. So just put that in your calculator. In fact, I'll do it myself here now because I feel all of a sudden insecure and I might have made a mistake. So that is that 144, 1225, I've done it correctly, plus 1, 1369 of that. And of course, that's a perfect square root. So 3.7 over q is equal to plus or minus, that will be, of course, your 37. That's what I said when I looked at this question, 37 over 35. Okay, of course, that's your q in there. So we found the value of q as 2 different numbers, which is, of course, let's perhaps, I could use a calculator again, sorry. Multiply both sides by 10, 37 over q, so I'm going from this line here. Don't forget your plus or minus is equal to 370 divided by 35. So your q times the cross is equal to plus or minus, and you got the 35 on there, and the 10 over there. So you found that your q is, of course, plus or minus 3.5. The question, I'm just leaning across this easy, positive constants. P and q are constants, so it doesn't actually say. But, of course, q has to be the plus 3.5. If you look at this equation that has the q, if q is negative, time will always be positive because we are arbitrarily setting the clock at t is equal to 0. We cannot possibly get a positive number, and therefore your q there, even if you didn't do the plus or minus, perhaps I've thought of that already, I would have said maybe a work, but it's done now. And of course the p now can be found very easily from this equation here. So p is equal to 12 over 35 times q. P is 12 over 35. Why did I put 3.5 there? I don't know, it's because I was going to write for the Q the 3.5, and of course you can use your calculator. So your P will be 12 divided by 35. My brain now is started to misfire. Times 3.5 got, and I got this as 6.6 over 5. P is 6 over 5. I hope I haven't made any mistakes. If I have, please forgive me. Does that work consistently with the two equations? Oh, I always do check what do we have in there. So P, QT, Q turned out to be 3.5, so T is equal to 10, and 10 for your time times 1.2, it gives us our 12. So these are the correct numbers. I hope you follow this question. It has just basic ideas from vectors, but there's a bit of algebra to play around with and to try to come out of that with your equations. But overall, not a particularly difficult question, which I hope most of you can cope with. I'm going to be signing out, and I'll see you real soon. Bye for now.